Okay, let's look at example 12.20. Compared to 12.18, 12.18 was parametric, meaning we had r as a function of t and theta as a function of t. This one is not. We have this, I guess, a fork that is rotating in this direction with some theta dot angular velocity and some theta double dot angular acceleration. It's going on this path of a cartoid, and if you notice, the cartoid kind of goes in right there and follows that orange dotted line. They give us that at this instant the velocity is pointed down, tangent to the path at 4 feet per second, and the acceleration is 30 feet per second. Now the acceleration is probably going to be pointed like this. We'll find out. But this is at the instant. Theta is 180, and they're actually measuring from the x-axis like a good book. Okay, so we have r. R is equal to 0.5 times 1 minus cosine theta. We can find r dot right away. R dot would be equal to the constant 1.5. What's the derivative of 1 minus cosine? It would be a positive sine theta. Then we'd have to multiply by theta dot. Okay, then we want r double dot. We can say, copy the 0.5 down. This would be our f, and this would be our g. So f is sine theta, and g is theta dot. G prime is just theta double dot, and f prime is cosine theta. So we get 0.5 times the cosine of theta times theta dot times theta dot. And we also have a 0.5 times the sine of theta double dot. Okay, yeah, sorry, forgot that theta dot right there. Okay, evaluating at theta is equal to 180 degrees, we can find r is equal to a foot. We can find r dot is equal to 0. That means that went away, right? The sine or y value at 180 degrees is 0. That doesn't mean the acceleration is 0 though. Go ahead and plug in values. You'll get an r double dot equal to a negative 0.5 theta dot squared. Okay. Using these and the fact that the velocity is 4 feet per second, we say the velocity or the magnitude is equal to the square root of r dot squared plus the other component, r theta dot squared. And we get 4 that was given to us. We know r dot is 0. And we know r is 1. We don't know theta dot, so we can solve for it. Theta dot ends up being 4 radians per second. Alright, that's one thing they wanted to know. And so we can take it one step further. The acceleration, we went ahead and took derivatives. I recommend going all the way down to the second derivatives. The acceleration would be equal to the square root of r double dot minus r theta dot squared, all squared. Don't forget that second squared. Plus r theta double dot plus 2r dot theta dot. And that's all squared again. We were given that the acceleration, or the magnitude of the acceleration, was 30. They didn't tell us which way it was pointing, but it's 30 right there. And we can start plugging stuff in. We know our R double dot came out to a minus 0.5 times 4, whoops, minus the R is 1 and the velocity is 4 again. This whole thing needs to be squared. And then we have the other component where R is 1. Theta double dot is what we're solving for. And the other term we can neglect, but I'm going to go ahead and write it out. R dot was 0. So this whole thing goes away. But we still have that term, and we're solving for theta double dot. And we can get an 18 radians per second squared. Alright, so that was starting with R as a function of theta. We found the R dot, the velocity in the R direction, R double dot, the velocity in, or the acceleration in the R direction, and they wanted us to find the transverse components of velocity and acceleration, theta dot and theta double dot.